Hi, this is Steve Walker for Sciencetech. Today, I'm going to show you Sciencetech's Flash Solar Simulator Concentrator, the FSSC-4000. This highly specialized instrument is capable of producing enormous concentrations of light over a 50 by 50 millimeter area, very high intensities and very high uniformity. The target plane is located down here at the end of this homogenizing system. At the top of the system, we have a flash head. Inside, there's a xenon flash lamp. The specialized homogenizing system takes the power from the flash lamp and distributes it evenly over the 50 by 50 millimeter target at the target plane. It also allows us to capture most of the power, producing extremely high sun levels. The FSSC-4000, in fact, is capable of achieving sun levels of 4,000 suns at the target plane, and as low as 110 suns at the target plane. At the middle of the FSSC-4000, we have a location here where a filter can be placed. Filtering in a flash lamp system is a very important concept to get across. The reason is that the shape of the spectrum of the xenon flash lamp changes depending on the intensity of the flash or the energy that the flash lamp is going to be producing. That means that the spectrum produced by the FSSC-4000 is different when we operate at the very high power level than the spectrum that's produced when we operate at the very low power level, which is still extremely high. This is the power supply used with the FSSC-4000. It's an Elinchrom flash power supply, commercially available and easy to replace. Now we simply just have to turn on the power supply and then set the power level here using the up and down arrow keys. Now I'm going to show you how to operate the flash simulator, which is a very simple device to operate. We have a power level on the Elinchrom flash supply. Here you can see the number is 3.5. That's the lowest possible level on the power supply. It actually refers to a photography f-stop. At 3.5, we will be operating at 250 suns at the target plane. And we'll have to wait a minimum of 10 seconds between flashes. I'm going to flash now, pressing this button on the supply. The reason we have to wait in between flashes is for the lamp to cool down here. Inside this enclosure, there's a linear flash lamp surrounded by mirrors. The cooling is such that we need to wait for some time for that lamp to cool down. If we don't wait long enough, there's a risk that we may damage the lamp or the mirrors. I'm now going to increase to the maximum level allowed by the concentrator, which is 7.5. You should never flash past 7.5 on the supply. You should never flash at any number higher than 7.5. Okay? Now this, at 7.5, will produce 4,000 suns at our target plane. I'm going to flash now. The pulse from the lamp is approximately a 1 millisecond wide pulse, plus minus 5% at its peak. The pulse itself spans over about 15 milliseconds. When we flash at 7.5 on the power supply, we have to wait a minimum of 110 seconds in between flashes. If you flash at a rate higher than that, there's a risk that you will damage the instrument.